for section 1.3, we are going to talk about exponents, roots, and order of operations. Okay, and once again, these are all kind of things that we've done. Your calculator is going to be a really good tool to do on some of these things, especially the exponents and the roots part of it. When we get when we get to the order of operations, we're going to see some problems today that have like a bunch of steps to them or a bunch of different things that we have to do, and we're going to kind of break it down. We're going to talk about we've got to do it in a specific order, because if we don't do it in a specific order, then we might get a different answer. In fact, I got a problem that I'm going to give you that has a bunch of different things, and I'm going to kind of just throw you and see what you guys get, okay? And so we'll do that when we get to order of operations. All right, so first of all, exponents. Okay, we know what exponents are. Exponents is when we take a number, a base, and raise it to some power. One thing that I would say is when we do this, we can do stuff like this on our calculator, but we got to be really, really careful about when we do stuff on our calculator versus how we're going to put it into our calculator. So when we have an exponent of 4, what that means is we're taking -2 times itself 4 times. Okay, and I'm not expecting you to write this out every time. Like if I have -2 to the 4th, we don't necessarily have to write it -2 times itself 4 times, but just kind of understanding why the answer is what it is. -2 times -2 is 4. -2 times -2 is 4. 4 times 4 would be 16. So when we put this into our calculator, we should get 16, okay? And there's lots of different ways you could go about it. You could multiply it one thing at a time, but you got to watch your signs, your positives, your negatives. That's a really big part of our answer today. On the one to the right, very similar problem. Obviously, no parentheses, and so no parentheses really changes things here. We've got a negative on there, okay? But the negative is not attached with the 2. So when I write this one out, it's really this. The negative stays where it's at because it's out in front. And then 2 is raised to the 4th power. So we're going to multiply all these 2's together and then put negative on our answer. Okay. And it really kind of depends on the type of calculator that you have. Depending on the type of calculator you have to be careful, and you have to kind of know how it's doing the work, right? Calculators are really smart, but they only do what you tell it to do, basically, right? And so you've got to make sure that if it's supposed to have parentheses, how am I going to put that into my calculator versus not having parentheses? So very, very similar type problems, but how we put that in and everything will be really important as well. If I were to do an odd exponent, same idea, right? Nothing really is any different here except we have an odd exponent, okay? And odd exponents are going to change things a little bit because I'm taking a -6 times a -6 times a -6. So essentially, if I have a odd number of negatives, my answer will be negative. I've got 3 negatives, so I'm going to end up with a negative answer. Up here, I had 4 negatives. I have an even number of negatives, so I'm going to end up with a positive answer. Okay, and so that's where just looking at the exponent itself will tell you what the sign's gonna be, and then you can do the math to get what the number would be. Okay, now what I want to show you here is that this one, if we wrote it out, this is what it would look like, because once again, the 3 is only on the 6, the negative is not connected with the 6, so the only thing that's getting cubed is 6, so 6 cubed is 216, and then I put a negative on my answer at the end, which would be negative 216. So I end up getting the same thing. So when you have an odd exponent, really doesn't matter if you have parentheses or no parentheses. It's really only when you have an even exponent, 2, 4, 6, 8, so on, that would matter. Okay, when we talk about roots, one of the things that you're going to see today is when we do roots, usually we talk about what we call the principal square root. Like if I said, what is the square root of 36? We just are really talking about the positive root of 36. But you're going to have a couple of problems today that are asking us to find all square roots, or whatever root it is that we're trying to find. So if I said find all square roots of 49, what I'm really saying is what numbers times itself will get me back to 49? 7, okay? 7 is the one that comes into our head right away, right? Is that it? Is there any other number that I can multiply by itself that would get me to 49? What'd you say? If you took 1 times 49, but it has to be the same number. It has to be itself. So like 7 times 7 would be 49. So on something like this, we said 7, but it's actually plus or minus 7, okay? Because if I take a negative times a negative, it gives me a positive, okay? So whenever it says all, find all square roots, we got to include that plus or minus on there, okay? If it doesn't say find all square roots, then we're just talking about the principal square root, which is just 7. If I said negative 36, what happens if I take the square root of negative 36? Nope. Absolute value, yes, right? We talk about absolute value. Absolute value of a negative makes a positive. Okay, try it in your calculator. If you got your calculators, take the square root of negative 36. Oh, you need one?
Wait, the square root of negative? It says error. Carolyn, is your throat still on the inside? No? It went away? That's good.
But he's gotta go. But you might, I think you're gonna pull up a greater convex dimension. Yeah. You're gonna go from 3 up. Three O.
Go louder.
Yeah, you said that. You said that?
Go louder.
Did I already give you one?
Yes.
Did you get it done? Okay.
Thank you. Nice.
Oh, for real?
Full pack of batteries.
Hey, look how confused.
Well, I don't think it would work if there wasn't.
I was here for
Well, even if there wasn't, it could be not, here, that's fine, batteries could not be working.
I hate Spider Backer.
But it could be not your own.
I just had that
I
Which
know.
one not?
Corners and like walk really crazy.
No, hey,
Wait, you could do
I'm
the backwards, the
making-
backwards one.
I'm gonna be making
Yeah, I mean, but.
Dude, you should do it on the iPod.
Wait, Dave's gonna
Yeah.
open.
what?
Might as well bring that back. Seriously.
It's like a deeper meaning to that.
I like it. I did. It was scary, but
Oh, I don't know.
it was like it was deep.
It was like uncomfortable.
Yeah.
When she
When she peed on the ground? Yeah. And then like, I'm sorry, if someone gave me my own hat like
Cool.
Okay, well, somebody was possessing herself.
All right, what did we find out here?
No, it's error.
Yeah, it's an error, right? And so what we would say is that there is no real square root. Okay, why is it an error?
Because you can't take the square root of a negative.
Can't take the square root of a negative, okay? You can never take the square root of a negative because there is no number that I can multiply by itself to get me back to a negative, right? I could take 6 times negative 6, but those are two different numbers. It has to be 6 times 6 or negative 6 times a negative 6. It has to be the same number. There's no number that would get me to a negative 36 that's real, so there's no real square root. As we talked about, we have the principal square root. Okay, and when we talk about the principal square root, the reason I say that is because it's just going to say evaluate the root. Okay, so if we ever have a problem where it just says evaluate the root, then we're not looking for all roots, we're just looking for the principal square root. So if I said the square root of 64, if I said what are all square roots, I would do plus or minus 8, right? But here I just want the principal root, which is 8. We don't have to put the plus or minus on it. The plus or minus is only needed when we ask for all, or if we were like solving an equation. If I said something like x squared equals 64, then we know 8 times 8 is 64. We know negative 8 times negative 8 is also 64. So that would be another scenario where I would want to put plus or minus on it. Okay, so that would be more like what we did up here, where we want to find all roots if we're solving an equation. But if it's just saying evaluate the root, all we need is the positive answer itself. If I gave you like a fraction, square root of 81 over 100. Okay, there's a couple different ways that we could evaluate this. But when we look at roots, we should be able to recognize the first 10 perfect squares. Okay, and maybe you know more than that, but if I see anything in this list, I should immediately know, boom, that's a perfect square, okay? We know this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way down to 10 squared, okay? We have to identify those numbers. And if we can, then I know when I do this problem here, the square root of 81 over 100, I know the square root of 81 is 9, square root of 100 is 10, and so I can simply just rewrite this as 9 over 10. We take the square root of the top, we take the square root of the bottom individually, and that would be our answer. Okay, we're even going to see it today where we're doing the square root of a decimal. Okay, I'm not going to necessarily ask you to know how to do that in your head. You can use your calculator. So if we take the square root of 0.09, what do we get? How much?
3.3.
0.3.
Forgot how to put it in the calculator.
Okay.
So your square root and your square of x squared.
Sometimes this is our year.
Do I have to throw these back?
If there's
We
nothing
use
after
this
that,
is what we're doing.
I don't want to be that guy, but.
He was making one just close.
Yeah.
Not gonna count it. So we're gonna-
Those are shit.
That was like that was like a bad call.
it could be either one. I would take either one of those answers.
Yeah.
Yeah, good question. Some calculators are going to give it to you as a decimal. Some are going to give it to you as a fraction. I would take either one. The only time where I would probably prefer the fraction is if it's like a repeating decimal. Like rather than writing 0.333 repeating, right? I would rather you write 1/3. 1/3 would be the quicker and easier way to write it. So most of your calculators have a button that will transfer back and forth from fraction to decimal. If you don't know where that's at, I can show you. But graphic calculators definitely have that, and that's a pretty cool tool to have where you can change it from one to the other really quickly. Okay. Square root of 0.36. Okay, so those are all what we call square roots. Now we're going to look at some other roots. When we do a square root, the number that is assumed to be out here is a 2. But if there is no number there, then we assume it to be a 2. Okay, if we're going to do a different root, then we're going to have a different number on the outside of that radical sign, that root sign. And so what that's going to look like, and I think you've probably seen these a little bit before, is the cube root of 125. Now this one, some calculators have just the square root button and have just the cube root button on their calculators. Some, you will have what is called the xth root button, or maybe the nth root button. Kind of depends on the calculator. And how to put that in is a little bit different. Typically what you have to do is you have to put in the number first, the root first, and then make sure you're using this, not the square root. Those are two different buttons. Use the xth root and then type in whatever the number is. So try typing this one into the calculator. It could either be a cube root or it could be using the xth root button. And if you need help, let me know and I can show you how to do this one in your calculator. 5. Should be 5. Bless you. Okay, anybody need help finding that? Anybody remember where that's at? Okay, here's something to point out. Just a second ago, up here we said the square root of a negative, right? We said if I try to take the square of a negative, we can't do it. And that's true. What happens if I try to take the fifth root of negative 243? Try putting that one in your calculator. Negative 3. So as long as this number here is an odd number, I can take the root of a negative number, an odd root of a negative number. Okay, if this is even and this is negative, then we would say no real root. Okay, but if it's odd root and a negative underneath, we can do it. And really what we're saying here when we do roots is if I take negative 3 times itself 5 times, all of these things multiplied together are going to get me back to this number right here. Okay, so just trying to understand what the answer is telling me. Okay, why is it negative? Why does it work? Because, like we said earlier, we have odd number of negatives. So when we have an odd number of negatives, that's why we can end up with a negative underneath. If I had an even number of negatives, then it's always going to have to be a positive number. So that's why for an even number, we always have to have a positive number. Okay. Yeah. Yeah. Okay. So for that one, you're going to hit 5 first. Next group. Oh, yes.
Where from?
It was. Okay, everybody good with how to put that one into the calculator? All right, so we have times, so that's just the square root of it. So we gotta go 5, and then we gotta go, it's not long here, so we gotta go,
Do you like triple T?
and we gotta go down to the x through button number 5.
Here's my favorite.
And then to, so yes, if the root is just 2 or there's no root out there, then you can always use that one. But if there's a different root out there, then you have to go with that. Okay. Let's try this one. 4th root of 16. What number times itself 4 times?
2.
Give 16. You did that in your head, right?
Yeah.
Of course.
Why is that your calculator out?
Okay, so exponents and roots, we can do a lot of that in our calculator. We're going to have some of those kind of within. We're going to be doing some PEMDAS, some order of operations stuff here in just a second. So just kind of understanding those and how to find those is going to be a really big deal. Okay, so order of operations. Okay, math is sequential, right? Math, we got to be able to do things the right way, in the right order to get where we need to be, and that's what the order of operations is all about. If we didn't have the order of operations, then it would be mass chaos, right? Because then anybody could do any operation or anything they wanted to in any order they wanted, and we could get 15 different answers. But we have to have an order of operations to tell us this is the correct way of doing the work. Okay, and so basically we have, even though it's usually broke down into 5 letters, it's really 4 steps. Okay, so you might have heard PEMDAS way back when you started doing the order of operations. I always learned it as please excuse my dear Aunt Sally as a way of remembering PEMDAS. Maybe there's other ones that you've heard, or your teachers had a different way of helping you to remember, okay? But one of the bad things about doing it this way is a lot of people think we're going to do it in this order, okay? We're going to do subtraction last no matter what, and that's not necessarily the case. What we got to remember here is that these two steps happen at the same time, and these two steps happen at the same time. And I'll show you why that matters here in just a second, but we're going to go through the order of operations first, then talk about it, and then I'll show you some examples where you got to be kind of careful of making sure you do things in the right order. P represents parentheses. Okay? But I would probably, and that's just the way we've learned it, so I'm going to stick with that, but it's not just parentheses, it's any grouping symbol. So it could be parentheses, it could be brackets, it might even be absolute value. If I have something inside of an absolute value, I got to do that first because we're grouping everything inside of that together. So I probably would prefer to say any type of grouping symbol. Yeah.
Does the set count as parentheses?
It could, but like if we were evaluating, we don't necessarily see those brackets within something like that. But it could if we saw it. Yep. Okay, so these would probably be the ones that we would most commonly see. There might be a few other things, but probably these are the ones that we're going to see the majority of the time. Okay, second one is exponents. After we do all grouping symbols, now we're going to get rid of all exponents. Okay, any exponent, something raised to the second, something raised to the third, whatever that's going to be, we get rid of all exponents. And here's the part where we are talking about we're going to do all multiplication or division, but we're going to go from left to right. Just like we read a book. Okay, we're going to have this big long expression, and we're going to do everything we need to do, but we're going to do from left to right. Okay? And we'll talk about that here in just a second. Same thing goes for addition and subtraction. We're going to do all addition and subtraction from left to right. So if I have subtraction show up before addition, I do that first as I'm going through the problem. And that's probably one of the most common mistakes that I would see us make. And the main reason for that is because when we say PEMDAS, we think multiplication always comes for division, but not necessarily. So if I said 8 divided by 4 times 6, I have to do the division first. 8 divided by 4 is 2. 2 times 6 is 12. Okay? If I did the multiplication first, that would give me 4 times 6, which is 24. And if I took 8 divided by 24, that gives me 1/3. So my answer is quite a bit different there, right? 1/3 versus 12 for my answer. You can still get an answer, but that answer would not be correct. And so that's probably one of the things that gets missed the most. Same would be true for addition and subtraction. If I said 6 minus 2 plus 7, we've got to do the subtraction first. 6 minus 2 is 4. 4 plus 7 is 11. If I decided I was going to do the addition first, 2 plus 7 is 9. 6 minus 9 is -3. So that's a completely different answer. Okay? And so that's the part where you got to really keep it straight, is all addition and subtraction happens at the same time. As I go from left to right, the first addition or subtraction sign I run into, that's the first one that I would do if there's multiple ones in the problem. Okay, so I'm gonna put up a big, long expression here for you, and I'm gonna see what you guys get, okay? You guys feel confident with order of operations? Yeah? Okay, let's see what happens, okay? Yeah, try to do it on your own, and then we'll compare answers, and we'll see who gets it right or what happens. Okay, and these are absolute value symbols here. Okay, I'll give you a couple minutes to try to work that out. Come up with a solution, and then we'll see what we got. Follow the order of operations as you go through it.
Team versus team 1 versus team A. We're team A. We're team together. This world. Fine.
Please give me my highlighter back. Okay, now you guys can't learn.
Okay, well, we have 2 calculators.
So you don't work. It's okay.
No, I'm doing it. Come on.
Give me my highlighter back. Yeah. What did you times it by 3 or add 3?
What?
What did you do for this?
I did minus 3.
This is division. Guys, this is
So it would kind of be like, so you gotta do
Where'd you get? Oh, yeah.
first. Kind of like do parentheses.
But
Where'd you get minus
it
9?
could not be.
That's what I got. Wait,
So
Did
she,
you get negative 14?
no. I could be wrong.
Then you did it wrong because you get negative 4.
I'm still working on it.
You got it?
You got negative 14? But how did you get the 5?
No, I'm probably wrong.
I think I'm right. I think I'm right. I feel
If
confident.
everything's got negative 4,
So basically, I did 6. Did I do this? You got negative 14.
Me too.
Because I went. Because I
I don't know how
went
I
here
got
first,
that.
and then minus what I got here. And I did it here first, minus 3. Subtracted that, and then I did it here first, put the negative. My answers and that's it. Right here, I got.
You minus.
I did
Get fine.
6.
Nothing we can tell you because you don't want it, because we don't want you to know.
It's because you didn't get an answer, is it?
Not negative 14.
I didn't.
Did you get negative?
And also everybody else down the road got negative 14 and you guys didn't. So that's
This
This
is
is the
wrong.
whiteboard's terrible.
Yeah, I think it's like so long. He's like,
You didn't get an answer? You get an answer? In your heart. Oh, man.
Dexter also got.
It's gotta be right, it's in
Kingston
your
said
heart,
he did
right?
not get negative 14, and Fletcher said he's still working on
No, I got it though.
it. So what'd you get?
Negative 11.
Well done. Wait, what did you guys get?
hey, no, Fletcher.
Right here, girl power though. We still love each other.
Knocks,
I don't
guys.
even.
We still love each other. Oh, falling.
One of us gotta have it.
Can we?
Answer.
The paper one? Can you make a
Can we please make
crumple up paper and everything?
Oh, wait, no.
No, actually, I'm gonna do that. I'm gonna make it just for me. But you have to record it.
Wait, I'll record it. I'll record it too.
Wait, how?
But I'll just get my phone and I'll record you.
Do it, I dare you.
You have your phone? Here, Sierra, take it.
Okay, so here's kind of the fun part, or maybe you guys don't consider it to be fun, but every year when I do this one, okay, or when we do this, then we get lots of different answers, and that's okay, right? That is to show you why we have the order of operation. So I heard negative 13. I think I heard a negative 18.
Yeah, that's what
Yep.
I got too.
We got
Negative
that.
14.
Negative 14. Help me remember the answers we got.
Negative 32 right here.
Negative 32.
Yeah.
It
Yeah.
literally says on the board.
Okay. I think I remember a negative 8. Yeah.
What? 4 different answers so far.
Do we have any other? Was there
Whoever got the same answer.
was there a negative 11?
We got this and then.
No, I changed my answer.
Oh,
Yeah, negative 11.
I got 11 at first, then I changed it.
She's
What?
lying.
Oh yeah, the heart. Okay. Yep. There we go. The old heart answer. Okay. Forgot about that one.
Somebody put a word.
I got Jesus is the answer.
I think it's because they love me. Right?
Yeah, it was in my heart. The answer's in my
Yeah.
heart.
Yeah.
And Jesus is the answer.
Jesus is.
You took that from me. You really took that from me.
Unfortunately, if you put that on a quiz and test, it wouldn't go so well.
I put all Mrs. Morgan's
I'm gonna be
stuff
putting
in
that on
my
your
heart.
Okay. Was there any other answers?
Jesus.
I think that's it.
Okay.
All right, let's see the
You
review.
want to see it? All right. So
Wait, eliminate them slowly.
Yeah, yeah.
eliminate
You
them
just say
slowly.
eliminate, and then show us how to do it.
What if none of them were right?
That'd be really
Oh man.
If not, is that
Is anybody 100% confident that this
Yeah.
is the answer?
Right here.
Wait, can you at least tell us if one of those is right?
We're gonna find out. I hate to spoil a surprise. Okay, what would we do first? What do you think?
we would.
Parentheses,
The parentheses are
negative 2
brackets.
to the 3rd power.
Okay.
Yep.
Negative 8 minus 3 would be negative 11.
Okay. So here's what we got. Here's what we got to be careful. Okay. First step is parentheses or grouping symbols, right? So anything that's inside of some type of grouping symbol. So this would be considered a grouping symbol because there's an operation underneath the square root. So because there's something underneath the square root, I would want to do that. I would also want to do all of this because it's inside of the absolute value. This is not necessarily considered a grouping symbol right now. It's more considered an exponent because there's no operation to be done inside the parentheses. There's no like addition, subtraction, multiplication, division that we have to do inside the parentheses, right? So I'm going to leave this alone for right now because that exponents are really kind of our second step, right? And we're still on grouping symbols. Here we have a grouping symbol within a grouping symbol. We have parentheses inside of an absolute value. 4 plus 3 is 7. 5 minus 7 is negative 2. Okay? Minus the square root of 25.
Okay.
Okay?
Yeah.
So step 1 is done. Parentheses, grouping symbols are all done. Everybody with me there? Okay?
Yeah, we're with you.
Next step should be exponents, right? So exponents,
No, we didn't, but we did it.
negative 8.
We didn't get 25. Okay. I got 25. 16 plus 9 is 25, and then you put the negative after you put the 5. But you didn't put that in your paper, so I didn't know. Put it on my paper.
And we could go ahead and make this 5.
We're doing good.
Okay, and this, the absolute value, I think probably is where most of us went wrong.
Is it negative 18?
Because, remember the other day when we did absolute value, when I have absolute value, I have to take the absolute value of that number. So if I said, what is the absolute value of negative 2? If I got rid of all of this stuff, and I said, what's the absolute value of negative 2? What would we say? 2. Okay, so that turns into this. Positive. So negative 8 minus 3 times 2 minus 5.
Oh. We did not do.
Because we're taking this times this. I also saw some of you do this. Some of you took the negative 8 minus the 3, but there's a multiplication there. Okay? So that we can't do.
Wait, how?
I'm confused. So what's the answer?
Wait, so how did we get the multiplication?
No, we got it right, technically.
We're almost there. Okay? Negative 8 minus 6 minus 5, because we got to do multiplication.
Oh, it was? Oh, I didn't.
Negative 14 minus 5 is
Oh.
negative 19.
So nobody got it
One
right.
off.
So nobody got it right.
Nobody got it right.
No, you didn't.
Okay. I will give you the assignment tomorrow so you don't have to worry about it tonight. Okay? Because tomorrow is a review work
When did
day.
you say our homework was due?
Monday.